Alright, so next will be the identification of the compression and rarefaction particles. Okay, so how do I identify where is the compression and where is the rarefaction? Okay, so very first thing is that we must make sure that we know that compression is where all the particles are clustered together. So you can see right from the picture, initially there's no sound. So when there's no sound, the particles will be in their equilibrium position. After that, I put a speaker, so the speaker will cause disturbance to the air particles. So you can see that the particles right here, they are clustered together. The particles right here, they are clustered together, right? So this is known as your compression. But where is the center of the compression? So the center of the compression is where you need to compare before sound and after sound. So what do I mean by comparing before sound and after sound? So before sound, right, the particles is at the equilibrium position right here. So this is the before sound. Okay, after sound, the center of the compression should be in the same equilibrium position. So this part is actually the center of the compression. So we must know how to identify the center of the compression. So likewise, for rarefaction, okay, rarefaction wise, you must make sure that the particles are spread out. So for example, right, if you look at this picture, the second part, right, with the speaker on, the particles right here, they're actually spread out. Then the particles right here, they're also spread out. So same thing, how can I identify the center of the rarefaction? You look at before sound and after sound. So before sound is right here, right? So the particles are in the equilibrium position. After the sound wave is being produced, the center of the rarefaction should also be in the equilibrium position. So this is known as your center of the rarefaction. Okay, so of course, as a rule of thumb, later I talk about the so-called the displacement. The displacement of compression and rarefaction from the EQM position should be 0. Okay, so that is how we identify the rarefaction and compression. Okay, next will be the wavelength. So how do I know what is one wavelength for a sound wave? So this is also very simple. As long as the distance between one rarefaction to the next rarefaction, right, that will be known as one wavelength. So likewise, if you go from one compression to the next compression, right, that will be known as one wavelength. Alright, so that is how you identify the compression, rarefaction, and wavelength.